Good evening, guys, and welcome back to another night of Algebra with Miss Sackno. Tonight we're looking at measures of central tendency. To understand a set of data, you need to organize and summarize your data using a measure of central tendency. Mean, median, and mode are all measures of central tendency. So let's review mean, median, and mode. Your mean is simply the sum of the data values. And remember that sum is addition. So I'm adding the sum of all of my data values and then dividing by, that's that line right there, the total number of data values. Total number is how many data points I have. This is also known as the average. So let's look at some examples I have here. In this data values, I have 1, 2, and 7. So how do I find the mean of these data points? Well, the mean meant I had to take the sum of my data values. So sum is addition. So I have to add 1 plus 2 plus 7. That's done here. And then I have to divide by the total number of data values. So I have to divide by how many values I have. 1, 2, 3. So 10 over 3 equals 3 1/3 years. All right, the next thing that I need you guys to see here is that my 7 is way bigger than my 2 and my 1. My 7 is an outlier. An outlier is any data value that is much, much higher or much lower than my other data points. 1 and 2 are kind of similar. They're close by. 7 is way out. 7 is my outlier. The next value of central tendency I want to review with you is the median. And the median simply means the middle value in a set of numbers where my numbers are arranged in order. You have to put your numbers in order from smallest to biggest. I've done that here with my data points, 1, 2, and 7. And which one is my median? It's my 2. It's the one that's in the middle. Now, this brings up an interesting scenario. What if I don't have a middle number? So let's say that I take the ages of my 4 kids, and I want to know what the median age of my 4 kids are. I have kids ages 1, 2, 7, and 9. Well, I don't have a middle. The first thing to do is to make sure that your numbers are arranged in order. The second thing is to look for the middle numbers. What are my 2 middle numbers? In this situation, I have 2 and 7 that are my middle. And then I end up needing to find the mean of the middle 2 numbers. Mean is simply the sum of those data values divided by the total number. So the sum of my data values here, I've got 2 and 7 I need to find the mean of. So 2 plus 7 divided by 2 equals 9/2 or 4.5. So my median of 1, 2, 7, and 9 is 4.5 years. Median describes the middle of a set of data, and it's best used when I have data that has an outlier, like my 9, or up here, like my 7. Where I have an outlier, median tells me kind of what the middle grouping is. Mean is simply going to tell me what the average is and it's best at indicating a group of data when I do not have an outlier. So now we're back at mode. And mode is simply any data value that occurs more than once, or in most situations, it's going to be the one that recurs the most number of times. Now, it's possible that you might have a data set that doesn't have any mode. Let's look over here, 1, 2, and 7, the first data set I used up here at the top. No number is repeated, so I don't have a mode. Look at this. What if I had twins? Oh my, 2-year-old twins. Okay, so here my mode is 2. So it's possible that I could have one mode in a set of data. Or, if this is my set of data, I could have more than one mode. In that situation, both my 2 and my 7 are my modes. Mode is a really helpful way of organizing and interpreting my data when I have data that's non-numeric, meaning maybe my data is cookies and pies sold at a restaurant, or letter values of grades. What is the one that's repeated the most? Or maybe which one's most popular is, what's the popularity of cakes and pies and cookies? So the answer that's selected the most would become my most. At this point, you should have all of your vocabulary and key concepts box on page 42 of your note-taking guide completely filled out. I've given you all the answers at this point. If you don't, then you need to pause me, rewind me, and rewatch this set and make sure that you can get all of the answers for that vocabulary and key concept box on page 42. The last few answers are coming up. All right, guys, let's continue. Let's look at the last measure of central tendency. This is my range. All right, and range hopefully is not going to be super difficult here as a concept. Range is simply difference, and remember that difference is what mathematical operation? Oh, right, subtraction. So it's the subtraction between my greatest data point and my least smallest data point. So let's look at an example here where I gave you some data. If I'm taking the ages of my kids and I want to know what their age range is, I'm simply going to subtract my biggest data point and my smallest data point. And so the range of ages in my kids, they span 8 years. Okay, now let's look at just reviewing why these are important. Remember that measures of central tendency are used when or why? They're used to organize and to summarize a set of data. They're a way of helping me interpret data points, the grades in my class. As a teacher, you kind of want the majority of your grades to be C and above, recognizing that you're going to have a couple that just didn't quite get it and they're in the D's and the F area. As a baseball player, you might want to organize your stats and figure out your percentage of hits that are successful. You might want to figure out what your average batting is per game, or what is the most repeated number of times that you hit in a row, or the most repeated number of strikeouts per player, to figure out which player maybe needs some more practice or which one do you want to bench next week. So these are super helpful when looking at data in any field or in any sport that you're in. So let's look at making sure that you can remember these and that you can apply these. So to help you remember them, I've come up with this little ditty that I think I taught a while back to some of you. Hey diddle diddle, the median's the middle. You add and divide for the mean. Your mode is the one that appears the most, and the range is the difference between. All right, this sounds goofy and silly, but I want you to repeat it with me. Hey diddle diddle, the median's the middle. You add and divide for the mean. The mode is the one that appears the most, and the range is the difference between. Remember, difference is what? Subtraction. All right, let's try it one more time. Hey diddle diddle, the median's the middle. You add and divide for the mean. Your mode is the one that appears the most, and the range is the difference between. Good job, guys. Let's look at applying these now. All right, we're at the top of page 43 in your note-taking guide. We're doing example 1, applying the measures of central tendency. You have a data set right here. All right, they're not in order. It's just random numbers. And let's review our ditty. Hey diddle diddle, the median's the middle. You add and divide for the mean. Your mode is the one that appears the most, and the range is the difference between. I first want to find my mean. Mean is easy because I don't have to rearrange, but I have to remember to do the 2 steps. So remember that for my mean, I have to add and divide. So first I'm going to add 14 plus 10 plus 2 plus 13 plus 16 plus 3 plus 12 plus 11. Phew. Okay. And once I add, then I have to divide. So I'm going to divide all of this by what? Do I divide it simply by each of these data points again? No. I divide it by the total number of data values, if I'm looking back over here. Okay. So let's count what my total number of data points are. I have 1, 2, 3, 4, 5, 6, 7, and 8. So I'm going to divide all of this here by 8. All right, let's solve and see what I get. Hopefully you got 81 divided by 8. And now what I want you to do is I want you just to plug that into a calculator, and hopefully you're going to get 10.125. This is my mean. This is my average number. Then when I add all of these numbers up and divide it by the total number of items that I have, it's going to give me 10.125. All right, the next thing I need to find is my median. Sing your little ditty to figure out what median is. Hey diddle diddle, the median's the middle. Sweet, it's the middle. All right, so I have 8 points. 1, 2, 3, 4, I get here. 1, 2, 3, 4, I get here. So I'm going to have to deal with the 2 here. Oh, no, that's not right. Why not? Because median has 2 steps. The first thing I have to do is what? I have to write these in order. So let's check these in order. I have 2 as my smallest. What's next from 2? Good. Then I get 3. What's next? Okay. Then I get 11. Oops, nope, 10 comes first. Then I get 11, and then I get 12, and then I have 13, and then I get 14, and then I get 16. Okay, again, I want to find my median, so I need to go to the middle. So I have 8, so it's going to be in between 11 and 12. Well, how do I figure out what's exactly right in between 11 and 12? Some of you intuitively know that it's 11 and a half. But if I'm not sure, what I have to do is I now have to go back and I've got to use mean to find median. So I'm going to add 11 and 12 together and divide by 2, which gives me 23 divided by 2, which is 11.5. Good. So you notice that right here in between 11 and 12 is 11.5. That is my middle number. Okay. Notice that that's very different than saying the average of 13 and 16. You have to first rewrite your data. Remember to rewrite in order before you start doing anything else. All right, the next central measure that I need to find is my mode. Which one is the most often repeated? For this, it doesn't matter if they're in order or not. So I'm going to come down back to this blue set that I wrote here. And let's see if I have any that are repeated. Is 2 repeated? No. 3? No. 10, 11, 12? Nope. These are all their own value. So it means that I have no mode. That is okay. All right. Let's now look at summarizing from these measures. So remember that my mean was 10.125. The median was 11.5. And there's no mode. Okay, what do I do with this? Well, let's look at this a little bit more closely. So what's the difference between the mean and my outliers? If I'm looking back at where my mean is in this blue data set, it's saying that the average of all of these is somewhere here, right around my 10. But notice that really skews my data. It's saying that my data is more heavily interpreted as being on the lower end, where I actually have 1, 2, 3, 4. I have a full 5 values of my 8 data items. So 5 of the 8 data values are higher than my mean. Maybe my mean is not the best interpretation here. Well, let's look back here. 10, 11, and 12 are kind of close. 10, 11, 12, 13, and 14 are pretty close. 2 and 3 are way out here. If I'm thinking about this on a number line, I've got 2 and 3, and then 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got this huge gap in between. So these are my outliers. So if they're my outliers, maybe mean isn't the best. What is my median? Well, my median was 11.5. That puts me right squarely in the middle of my data points here. I think in this situation that the median best describes this data. It gives a more accurate representation of where my data is. Because more of my data points were higher than my mean is not a good indication. You might want to write that down. If I have more data points that are higher than my mean or my average, then my average is not a good indicator. In this situation, use median instead of mean. Okay, we're going to be looking at solving an equation next. At this point, we've done all of example 1 on page 43. So you should have all of that done. If you cannot find one of the answers for example 1, please rewind to the beginning of where we started working on this and go back and fill it all out. Let's look at a second example on the bottom of page 43 that actually is pretty realistic for you guys as students. It gives you a real-life scenario and wants you to work backwards to find the mean. So let's look at this. Your grades on 3 science exams are an 82, a 94, and an 89. What grade do you need on your next exam to have an average of 90? What does average mean? This is our key word here. Our data points so far are 82, 94, and 89. What is average? Well, remember that mean equals average, and that in order to find the average, I want to take the sum of my data points and divide it by the number. But that's not the same as 82 plus 94 plus 89 divided by 3. Why not? Because I have x, and x is a 4th exam. So if I want to find the average of an unknown 4th exam, I need to add in x. It's whatever grade I need to get on my next one. I already have the 82, I have the 94, and I have the 89. And remember, to find the average, you've got to divide by the number of data points. This is 1, 2, 3, and 4. Okay, so what average would x have to be if I want an average of 90? An average of 90 means that my average equals 90. So if this equals average and my average also equals 90, then I can end up simply setting these things in place of each other, like this. Whoa, look at this. This is what my average equals, and this is what my average equals. So I simply set up 90 in place of 1, and all of this in place of my other. And it gave me this guy here. Okay, now I have to look at solving this. All right, notice that I have x divided by something. And if I'm dividing x by something, what do I have to undo? I've got to multiply. Good. So what can I possibly multiply this whole quantity and this side by to get this 4 away? Well, I'm going to multiply it by 4 over 1. And what I do to one side, I've got to do to the other. Notice my 4's cancel out, and I'm left with 4 times 90 equals x plus 82 plus 94 plus 89. I need to combine like terms. What is 4 times 90? Well, that should be 360. And over here, this should be x plus 82 plus 94 plus 89. What does that equal? Hopefully you got 265. Well, now I still don't have x by itself. I've got to get x by itself. So I've got to undo this 265. So if this is positive up here, I need to make it negative down here. And what I do to one side, I've got to do to the other. What do I end up with? X equals what? Well, if x equals a 95, what does that mean for me? It means that my next exam has to be a 95 if I want to get an average of 90 in the class based off of the tests. So because I had an 82, a 94, and an 89, and I wanted my test average to be a 90, whatever I added to it had to be enough to bring my average up to a 90. And the only way I could bring my average up to a 90 would be if my test score was a 95. Before we go any further, I would like you to check your understanding on this process by turning over to page 44 in your note-taking guide and completing the check understanding number 2 and the critical thinking. It basically tells you that you have grades on 3 history exams that are an 80, a 93, and a 91. And if 100 is the highest possible score on your 4th exam, is it even possible for you to raise your average to a 92? You need to explain this and work out the problem just like I did up here. So you're going to plug your data points in for the ones that I have. Then you're going to follow the same process I did. So if you need to rewind the video, do that. Show me your work. Show me the answer to number 2, and then we'll proceed. All right, the next one we're going to do is example 3 on the bottom of page 43 in your note-taking guide. And we're going to be relearning how to make a stem and leaf plot. If we think of a stem and leaf plot as a tree, each of our branches represents the tens place, and each one of the leaves on our branches represents the ones place. The same could be said if you had hundreds or thousands. So let's look at this for a moment. If I have a stem and leaf plot for this data going on up here, remember that I said the tens place equaled my stems? Well, I'm going to end up writing my stems up and down. So I've got 50s, I've got 60s, and I've also got 40s. So these are my stems. Now for each of my stems, I'm going to end up with leaves off of each one of these. So let's look at 56. 56 has a stem of 5 and a leaf of 6. So when you're reading these, 5 like this equals 56, where my tens value are my branches and my ones values are the leaves that kind of hang off of my branches. All right, so I've got 56 dealt with. Let's look at 44. Which one is my stem? Oh, the 4. All right, what's its leaf? Another 4. Okay, got that one. Let's do 63. What's its stem? Its stem is the 6. And which one is its leaf? Oh, the 3. Okay, let's keep going. The next one I have is 58. Okay, 50 is the stem and 8 is its leaf. The next one is 51. 50 is its stem and 1 is its leaf. Uh-oh, we have a problem here. These should be in order of smallest to biggest. It should be something more like 1, 6, and 8. Okay, so before I go any further in my stem and leaf plot, let's make sure that we have these written out. So let's go back and let's rewrite our data out in order from smallest to biggest. So what is my smallest number? Well, my smallest number is 44. So I'm going to write that out. Remember that the 40 is my stem and my green 4 is my leaf. All right, I got 44. Next one is 49. What's the next one? I've got 51. And some of you might have already noticed that I have 2 51s. I've got this one and this one. All right, I took care of both of my 51s. The next smallest number, oh no, I forgot my 47. Fortunately, it's pretty easy to squeeze that guy in. So let's go ahead and make sure that we haven't forgotten any others. Oh, look at that, 50. All right, as long as you are writing these so that you have room, it's not the end of the world if you end up forgetting one. You just simply squeeze it in. All right, after 51, the next one I have is 56. And then 58. You should be doing this along with me. Your paper should look just like mine. And then we get into our 60s. 63. Oh, another 63. And look at that, I forgot 59. 66. And then I have 67. All right, now that I've got all of these, now I can plot my stem and leaf plot. Notice that I have 40s, 50s, and 60s. So my 40s, 50s, and 60s become my stems, and off of them are my leaves. So now it's super easy. I've got 44, 47, 49. I've got 50, 51, another 51, 56, 58, and 59. Then 63, 63, 66, and 67. Whoa. Okay, the cool thing about my stem and leaf plot is I can really easily see that my data is clustered in one particular area. Where do you think that is? Oh, good. My data is clustered here in my 50s. The majority of my data is in my 50s. I have a few in my 40s and a few in my 60s, but the majority of it is here. It would also be really easy using this to figure out what my mode is. What's my most repeated number? Well, the only digits I have repeated are my ones, but my mode is not 1. My mode is 51. And what about my median? What is the middle number here? Well, I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then 7. So my median is not 6. You got to put it with its stem. You can't have a leaf by itself. So my median is 56. And that seems pretty accurate. I've got a bunch of numbers to the above it. I've got a bunch under it. Median here seems to be a pretty accurate indicator. I don't have a bunch of outliers. It's all kind of clustered in the same area. All right, so what would something like this end up meaning? What number is that? Hopefully you notice that number is 51. All right, let's go ahead and move to page 44. It's the back page of lesson 2.7. At this point, you should be able to figure out the rest of the check understanding questions on the back of this page. Please do so on your own, and we'll see you in class tomorrow. Well done tonight, guys.